Good morning dear students, myself Sachin S. Pawar and I welcome you to my 6th video on Unit 1 Solid States for PU2 Chemistry students. In this video we shall discuss the calculations involving unit cell dimensions. So without wasting our time, let's begin our today's session. Okay, so let's go. The first part to be determined in today's class is the determination of the relation between the density of the unit cell, that is the density of the material, and the edge length of the unit cell. See, when I say unit cell dimensions, it is the number of particles present in the unit cell, that is the mass occupied per unit volume, that is density, and the edge length and the radius. So we have to solve problems based on that. For this we will derive first the relation between density of the material and edge length. So let's begin. Density of the unit cell. For this we consider the edge length of the unit cell as A. And when I say edge length of the unit cell is A, obviously the unit cell is made up of 3 edges, so the volume of that unit cell can be easily determined as length into breadth into height. And since we are taking a cubic unit cell here, length is equal to breadth is equal to height, therefore it is A into A, that is A cube. So we have got the volume of the unit cell. Why we want volume? Because we want density, and density is mass upon volume. Density is equal to mass upon volume. Therefore, let us consider that we have Z number of atoms in an element with atomic mass as capital M. Why we require this, I will tell you in a moment. So this is the preliminary, what I can say, our preliminary observations. So we will consider A as the unit length, A cube as the volume of the unit cell, Z, small z, as the number of particles per unit cell, and the atomic mass we will assume it as capital M. Okay. Here we know mass upon volume is density. Rho is a symbol for it. So density of the material is mass upon volume. Mass, now here density of the material is density of the unit cell we will take. Because unit cell dimensions we are taking, therefore we will consider density as the density of the unit cell. Because the unit cell is multiplied many times to get the entire crystal lattice that we have learned. So we will consider density of the material as the density of the unit cell. So to find that, density of the unit cell means the mass of occupied in the unit cell upon the volume, mass of the material in one unit cell upon the volume of the unit cell. In the denominator, the volume of the unit cell is A cube, you already know it. We have to find out the mass of the material. Now mass of the material, to find the mass of the material we have to take the help of PUC first year unit 1 chemistry for PUC first year slabs. And we know the mass of the material is the number of atoms into the mass of each atom, that is Z into M. So if you know exactly how many atoms are present or how many particles are present in a unit cell, and if you multiply it by the mass of each atom, then you will get the mass, that is the numerator. So here and again, mass of each atom can be found. Mass of each atom can be found out by a simple formula which you have learnt in your PUC first year unit number 1. Molar mass upon Avogadro's number. Avogadro's number is 6.022 10 to the power 23. Molar mass can be atomic mass for elements, molecular mass for molecules, formula mass for ionic compounds. So we have got here the mass numerator value. So we'll substitute density is equal to mass upon volume. So it is Z into M upon A cube, where M can be written as mass of each atom, can be written as molar mass upon Avogadro's number. Therefore we have got a formula, and this is the formula for calculating density of the material, which is Z into number of particles present in the unit cell into mass of each atom upon A cube, that is the volume of the unit cell. Or if you want in terms of if you have the molar mass, then Z into capital M, that is molar mass, upon edge length cube into 6.022 10 to the power 23. With this, let's begin our today's session on solving problems on these equations. Okay, So we have a formula, problems on calculations involving cell dimensions. Okay, so density is Z into capital M A cube upon A cube into Na, where Na stands for Avogadro's number, per mole is unit for it. Molar mass has no unit, but we always write it as grams per mole. Remember this. Number of particles can be found out by a formula, and you know that formula is 1 by 8 into number of corner particles plus 1 by 2 into number of face centered particles plus 1 if there is a body centered particle. Sorry. And density by definition is mass upon volume. Whenever we require, we have to use this. Let's begin this. Now here you require to use two formulas which are required for our problems, not all problems but some problems. If you want to find out the number of particles in a given mass of a material, if you want to find out number of particles in a given mass of a material, then we have to just find out the number of particles per unit cell and multiply it by the number of unit cells present in the material. Number of unit cells present in the material, and the number of particles per unit cell can be found out by the formula. Number of particles per unit cell is number of unit cells in the material upon number of particles in the given mass of the material. How to use that, when to use that we shall see when the problem comes. Let's begin the today's problem. The first problem. Kf has sodium chloride structure. If the distance between the K plus and F minus is 269 picometers, find the density of the Kf. Na 6.02 into 10 to the power 23 per mole. Atomic mass of K is 39 and F is 19 AMU. AMU stands for grams per mole, unified mass also it is called as. Now they have asked me to find out density, so the formula is Z into capital M upon A cube into Na. Here they have given me that Kf has a structure of NaCl, and you know NaCl is a standard example for face centered cubic system, and therefore Kf is having a face centered cubic system. That is the outcome of the first statement. Okay, we require molar mass, so we'll calculate the molar mass. Molar mass of Kf is sum of the atomic masses, that is 39 plus 19, that is 58 grams per mole, that we have calculated. Kf is sodium chloride, therefore it is a FCC, therefore the number of particles per unit cell is FCC is you know it as 4. Number of particles present in BCC is 2. Number of particles per unit cell in simple cube is 1, that we have already derived. Okay, so there was some disturbance, I'm sorry. Okay, so Kf is NaCl, therefore it is a FCC, therefore the number of particles per unit cell FCC is Z, that is equal to 4. We have got Z, we have got M. We have got Z and we have got M. We want A. For this they have given distance between the K plus and F minus. Distance between K plus and F minus means distance between the nearest neighbor they have given. And for this, in my previous video I have already given the relation which you have to by heart. This chart I have already given in the last class. For FCC, the distance between the nearest neighbor is A upon root 2. Therefore, A is the edge length is equal to root 2 into distance between the nearest neighbor. Distance between nearest neighbor is 269 picometers. 269 picometers. Therefore, it is root 2 is 1.414 into 269 picometers. Picometer is not the unit, so we'll convert it into centimeter. Pico is 10 to the power minus 10 centimeter, so it is 380.4 into 10 to the power minus 10 centimeter. We have got. Therefore, A cube I will find out, because in denominator A cube is there. So A cube comes out to be 55.05 into 10 to the power minus 24 centimeter cube. A cube we have found. Let's substitute now. Z is number of particles, that is 4. 58 grams per mole. 55.05 into 10 to the power minus 24 is the A cube, and Avogadro's number is 6.02 into 10 to the power 23 per mole. So if you just cancel per mole, unit will become grams per cm cube, and the answer comes out to be 7 grams per cm cube. This is the answer. This is problem number 1. Let's quickly move on to the next problem. Density of KBr is 2.75 grams per cm cube. The length of the edge of the unit cell is 654 picometers. Show that KBR has FCC, that is face centered cubic structure. Na is given as 6.023 into 10 to the power 23 per mole, and atomic mass of K is given as 39, Br is given as 80. Okay, so they have asked us to prove that it is face centered cubic structure. Now when problem is coming like this, that is you want to decide whether it is a face centered cube or a simple cube or a body centered cube, then we have to just by heart the number of particles present per unit cell in those. Number of particles per unit cell in simple cube is 1, in body centered cube it is 2, and in face centered cube it is 4. So if you find out the number of particles per unit cell and if you find it as 4, then I can easily say that since the number of particles per unit cell is 4, it is FCC. For this, what they have given? They have given density, they have given the edge length, and the number of particle is not given, which we will find it. So again the same formula to be used, same formula to be used. So density is equal to Z. Okay. So the number of particles can be easily be found as Z is equal to d a cube Na upon m. D is the density given as 2.75 grams per cm cube. I will substitute. A is given, so a cube can be found 6.54 into 10 to the power minus 10. See, they are given A as 654 picometers. We have to convert into centimeter. The reason for that is density is given in centimeter. Density is given in centimeter per centimeter cube, therefore I need to convert picometer into centimeter. So it is 654 into 10 to the power minus 10 centimeter whole cube into Avogadro's number upon molar mass. M is 39 plus 80, that is 119. So we substitute and the answer is coming out to be 3.89. You can approximate as 4, and since the number of particles per unit cell is 4, you can say clearly that KBR is a face centered cubic lattice. This is the problem on calculating what kind of unit cell that substance is or the material is made of. Next problem. An element having BCC crystal structure has an atomic mass of 50 AMU and a density is 6.81 grams per cm cube. Calculate the edge length of the unit cell, they have asked. Calculate the edge length of the unit cell, they have asked. So simple formula is density is equal to Z into capital M upon A cube into Na. So A I have to find out. For this, M is atomic mass, that is 50 AMU. I can express in grams per mole. Why we want? Because we want to cancel the common units. Edge length has to be found. A not given. Element is BCC, so we want Z. Z is number of particles per unit cell. For BCC, number of particles per unit cell is 2. You already know it. So I'll substitute that. Density is given as 6.81 grams per cm cube. I will write here. Avogadro's number, it is not given, but we have to by heart it as 6.023 into 10 to the power 23. 6.022, 6.023, whatever is given, we have to accept. Therefore, A cube I can find out very easily. So Z 2 into 50 grams per mole. Density, substitute. I will get A cube as 24.4 into 10 to the power minus 24. I have got here A cube. Now I have got A cube. I want to find out A, and for that I have to take the cube root of this. Now in your annual examination, a simple 8-digit calculator is allowed. Simple 8-digit calculator is allowed. And in simple 8-digit calculator, the cube root of any value I can't determine. So for that I need to use log table and anti-log table. So for this, what I'll do is I will first take log on both sides. So A, I will get it as A is equal to 24.4 into 10 to the power minus 24 raised to 1 by 3. So log A will become log of 24.4 into 10 to the power minus 24 raised to 1 by 3. I can use log table here. I have just taken a snap of log table for required row. So, and I have to use the formula log of AB, that is log of A plus log of B, and log of A to the power X is X log A. So here this can be written as 1 by 3 into log of 24.4 plus log of 10 to the power minus 24. So if substitute becomes 1 by 3 into, I want to find out log of 24.4. Now to find log of 24.4, the characteristic becomes, okay, the point is after log of 24.4. Okay, so log of 24.4 I have to find out. For this, the point is, the decimal point is after 2 digit, therefore the characteristic becomes 1. And in log table I need to see 24th row 4th column. So in log table 24th row 4th column is this one. 4th column is this one, that is 3874. So it is log of 24.4 is 1.3874, and log of a to the power x is minus 24 log 10. Log 10 is 1, so it is 24. So 1.3874 minus 24 is minus 7.5374. So I have got the log value. So log of a I have got. Log of a. Next, I want to find out a. I don't want to find log a, I want to find a. So I'll take antilog on both sides. So antilog is minus 7.5374. Minus 7 I have take. Now here I have to just explain you something. Okay, just a minute. So I will explain you some very important thing here. Okay, now when I take log, antilog, I take antilog of any value. Okay, if the value is negative, so right now in this particular problem the value is you can find it as minus 7.5374. So it is minus 7.5374. So I will just write minus 7.5374. Now this becomes the characteristics. This becomes the characteristics, and after decimal point it becomes the mantissa. For finding out antilog, mantissa should be always positive. Mantissa should be always positive, and to make it positive, the system says that you have learnt in physics practicals. If you add 1 and subtract 1 from any value, like for this example, there is no change in the value. So what I'll do is I want to make this mantissa positive. This actually is minus 7 minus 0.5374. So this is the mantissa for this, and this is the characteristics. So to this mantissa I will add plus 1, and to this characteristics I will add minus 1, and that way we can convert the mantissa into a positive figure. A negative mantissa can be made into a positive figure. How? Let's see. So here minus 7 minus 1 becomes minus 8, minus, now here this is 1.0000. See, I am adding minus 0.5374 subtraction. So here 10 minus 4 is 6, 10 minus 8 is 2, 10 minus 4 is 6, 10 minus 6 is 4, 1 minus 1 is 0. So I have got a positive figure. So this is plus 0.4626, and now I can write this as bar 8.4626. I hope this point is clear. How to make the mantissa positive for taking the antilog, I have explained. So here the mantissa minus 0.5374 is converted into plus 0.4626 by a simple method of using a mathematics that you have learnt in your physics practicals of logarithmic studies. So here I have added plus 1 and minus 1, and that what I have done here also. Just see, the same thing is done here. So you see minus 7 plus minus 7 0.5374 is split as -7, -1, plus I have added -1 to the characteristics, +1 to the mantissa, and finally I have got the answer as antilog of bar 8.4624. Antilog of bars 8.4624. Now in the antilog chart I have to go for 0.44th row, second column, and 0.46th row, second column, and fourth mean difference. For this also I have taken a snapshot. This is the antilog chart. I have to go for 0.46th row, and 0.46th row, when I go for second column, it is 2897, and there is a mean difference also 4. So in the fourth column is 3. So 2897 plus 3, 2897 plus 3 becomes 2900. So I have got the antilog as 2900. So to write the answer, we write 2. The decimal point is written after the first digit and multiply it by 10 to the power. The power here is the characteristics. So it is 2.900 into 10 to the power -8 centimeter is the answer. So this is the calculations involving unit cell, the edge length of the unit cell. I hope you have understood how to take the log and antilog, how to convert a negative mantissa into a positive mantissa whenever required. To convert negative mantissa into a positive mantissa, what we have to do is we have to add +1 to the mantissa and -1 to the characteristics, split that, and then the characteristics becomes bar, that is negative, and mantissa becomes positive. Now mantissa become positive means antilog can be easily be taken. This is the problem. Let's go into the next problem. Silver crystallizes in FCC lattice. If the edge length of the cell is 4.077 into 10 to the power -8 centimeter, the density is 10.5 grams per cm cube. Calculate the atomic mass of the silver. So they have asked to calculate the atomic mass of silver. So we'll do that. Silver crystallized in FCC means number of particles per unit cell is 4. Edge length is given as 4.077 into 10 to the power -8 centimeter. Density is given 10.5 into 10.5 is grams per cm cube. cm cube is same, so need not worry about it. Avogadro's number is it is 6.023 into 10 to the power 23 per mole. Okay. So I want to find out m. So using this formula density, we can express m on one side and rest all on the other side. So m becomes d into a cube into na upon z. So m is density 10.5 grams per cm cube. A is 4.077 into 10 to the power -8 centimeter raised to 3 into 6.02 into 10 to the power 23 upon 4. So on calculation, if you do it, the value comes out to be 107.14 grams per cm cube. See here, cm cube cancels. The unit will be grams per mole, not grams per cm cube, it will be grams per mole. Because cm raised to -3, cm raised to 3 cancels, and unit will be remaining is gram and per mole. So I have got the unit. I can write it as 107.14 grams per mole, or you can write 107.14, or you can write 107.14 AMU, whatever it is. So here we have used this formula to calculate the dimensions of the unit cell. Namely, we have a problem to calculate the density of the unit cell from knowing the other values. We have the formula for calculating the Z, that is number of particles per unit cell, by knowing the other values. We have a problem for calculating the edge length of the unit cell by knowing the other values, and we have a problem for calculating the molar mass of the material by knowing the other values in the same formula. Okay, let's go ahead into the next problem. Now this problem is the last problem of today's class. Slightly different. Purposely I have chosen this. Let's see what they have given. An element has a body centered cube structure, that is BCC structure, with a cell edge length of 288 picometers. Cell edge length is 288 picometers. They have also given the density of the element is 7.2 grams per cm cube. How many atoms are present in 208 grams of element? They have asked me how many atoms are present in 208 grams of element. For this, okay, what is given? I have written. It is BCC, therefore the number of particles per unit cell is Z. So I have the number of particles per unit cell, number of atoms per unit cell I have, that is 2. Edge length is given as 288 picometer. I will express in centimeter because density is given in grams per cm cube. So 288 into 10 to the power minus 8 centimeter. Okay. Density is given 7.2 grams per cm cube. Avogadro's number I know it as 6.023 10 to the power 23 per mole. I have to find out how many atoms are present in 208 grams of element. For this, number of particles in a given mass of element can be easily be found out by a simple formula, and the formula is number of particles per unit cell into number of unit cell in the material. Number of unit cell in the material. So if you know the number of particles per unit cell and multiply it by the number of unit cells in the material, then I can easily find out the number of particles in the given mass of element. For this, here in this equation, number of particles per unit cell is 2 because it is a BCC. So one part is already found. Now I need to find out the number of unit cells in the material. Number of unit cells in the material. Number of unit cells in the material is the volume of the material upon the volume of every unit cell. Volume of the material upon the volume of every unit cell. Now volume of the material is mass upon density, as we know, and volume of the unit cell is length cube, that is length into breadth into height. Since it is a cubic system, a cube, so a is known to me, so I can substitute the value of a in centimeter. Mass I can substitute because mass is given to me as, I have to find out in 208 grams, therefore 208 grams. Density is 2.7 grams per cm cube, so I will substitute, and on further calculation I will get the number of unit cell as 12.08 into 10 to the power 23. So I have got number of unit cells in the material, and we have also the number of particles per unit cell. So if you multiply 2 into this figure, you will get the number of particles in the given mass. The given mass is 208 as I have taken in the problem. So number of particles in 208 grams of the material is 2 into the number of unit cells, that is 12.08 into 10 to the power 23, and that is 24.16 into 10 to the power 23. Since it is a number, there is no unit for it. And see, as units are cancelled here, there is no units for this. And this completes the problems on calculating the number of particles per unit cell. This completes the problems on calculating the density of the unit cell, and the problems on this formula, which is D equal to Z into M upon A cube into Na. As far as your annual exam is concerned, it's very, very important to tell you, question number 27A is fixed for calculating the packing efficiency of simple cube, body centered cube and face centered cube. And in 99% question papers you see, there will be a problem on this equation. There will be a problem on this equation, that is density is equal to Z into capital M upon A cube into Na, which is a 2 marks. So 3 plus 2, 5 marks is fixed. Suppose this question, this problem doesn't come in, question number 27B. It is definitely there in question number 11 in part B section for 2 marks. So this problem is for 2 marks. 99% question papers, I will say, they have this question. So this problem are more important for you for your final examination. And in this problem we have seen, in this formula we have seen a problem to find out the density of the unit cell. The number of particles unit cell is going to be the shape of the unit cell, mass, the molar mass of the unit cell, edge length of the unit cell, and Avogadro's number. And this completes the problems on unit cell dimensions. Some more problems are remaining that we shall see in the next class. I'll stop here. Thank you.